All right, we're gonna look at 15.6, which is solving equilibrium problems. All these are more examples of what we looked at in the last video and what we looked at in your lab with the KEQ. Okay, so your steps here for writing equilibrium problems or solving them is to write the balanced equation for the reaction, figure out the equilibrium expression, and that's gonna be that K equals. Okay, you need to list the initial concentrations so you know what to start with. And they give you moles and liters, remember you gotta figure it out. You then need to calculate Q to figure out which way it's going to shift. Okay, whether you're going to have a plus X on the right or a minus X on the right as to which way it's going to go. And then you need to define the change needed to reach equilibrium. So that's the C in your ICE table. We did the I earlier. Now we did the which way it's going, positive or negative. Then we did the C. And then we need to substitute your equilibrium concentrations into your expression and solve for your unknown. So that's going to be that E part there. And then you can kind of check your equilibrium concentrations and make sure that they give you the right K value because you already know your K value for the most part on all of these problems. Okay, so let's look at a typical problem here. We have a synthesis of hydrogen fluoride from hydrogen and fluorine. I have 3 moles of H2, 6 moles of F2, and a 3 liter flask. Assume your constant for the reaction is 115, and we're going to calculate the equilibrium concentration for each component. And we actually looked at this exact same thing earlier, okay? Or exact same reaction. So I have my H2 plus F2 yields 2HF. I do my ICE table. So I start out with my equilibrium. We start out with my initial concentrations. So I have the I, all right? I know it's 1, 2, and 0 because it's 3 divided by 3 for H, 6 divided by 3 for the F, and it didn't give me anything with the HF, so then I know that that's 0. I need to figure out my change, which means I need to figure out my Q value. All right, well, if I figure out my Q value for this, the easy way to do this actually is to look and say, okay, if I have a 0, it's going to shift that way because you cannot use up something that you don't have. So this one has to shift to the right because I don't have anything on the right side, which means I have to then go that way. I can't shift to the left because you don't have anything, any products to make any reactants. Okay, so that means it has to go to the right, which means it's going to be a minus X, and it has to be a plus 2X because my coefficient there is 2. So I add straight down a column to get my equilibrium, which is the 1 minus X, the 2 minus X, and then the 2X. And then all we do is plug it into our K expression. So I get 115 equals 2x squared over 1 minus x times 2 minus x. You have to FOIL a little bit and get your quadratic equation. Okay, when you get these ones, this is where you need to plug it into your calculator, or you can do the quadratic formula. We can talk about this in class tomorrow with your calculator as to exactly how to plug these in if you don't know how to get your 2 options for that quadratic formula. One of them will not make any sense. See here we have 2 options. This 2.14 doesn't make any sense because 2 minus 2.14 is a negative number. I can't have a negative concentration. So that means my x has to be 0.968, and then I just plug it in to the 3 options that we have there for the 3 different concentrations. My 1 minus the x, the 2 minus the x, and the 2 times my x. And there are my 3 concentrations. Go ahead and try the next problem. All right, if we look at this next problem, it's very similar to the last one. We have my initial concentrations, I have my change, I have my equilibrium concentrations. This one actually you do have to figure out your Q, and when you figure out the Q, you should realize that it'll shift to the left, okay? I don't think I did that in here. So the Q is 5,000. Well, my Q is greater than my K, so it's got to go to the left. I need to use up all those extra products I have. That number is too big. It needs to be smaller. So then when I got my Q, I know which way it's going to go. So I know it's plus x minus 2x again. 2 because that's a coefficient of 2. Add straight down to get my E, so my equilibrium expression. Plug my equilibrium expression values in. remember to square it, okay? This is easy to forget to do. That coefficient actually kind of gets in here twice, in the 2x and in the squared, so make sure you do that twice, okay? We get our two things there, quadratic formulas after we FOIL, and I get these two. Combine your like terms. This one's a little bit more algebra. Combine your like terms, and we get this lovely quadratic formula. And again, plug it in your calculator. You have two options. And again, if you don't know how to do it in your calculator, we'll look at that tomorrow. And one of them's a negative number, so that one can't be it. That means my x has to be 0.0355. Plug it into my equilibrium expressions, or equilibrium concentrations for each thing. And this time, they're actually atmospheres instead of concentrations. All right, when we look at the last one, we're looking at systems that have small equilibrium constants, and small means usually negative exponents, things to the negative, usually second, third, fourth, fifth, sixth, seventh, that kind of deal. Those are small enough. Okay, so that means that those really don't make a lot of products. They have mostly reactants. So in that case, your K is so small that it's not going to go far on the X. Your X isn't going to be much. It's not going to shift by very much. So we can actually kind of do a little bit of a shortcut with small K equilibrium expressions or reactions. So we start out by writing our reaction again. We're going to do that 2NOCl yields 2NO plus Cl2. We write our I's, which are what they give us in the problem. Okay, I have 1 mole of the NOCl divided by 2, it's 0.5. I don't have anything of the other two because they don't give me any there. I have to know that it has to go to the right because I don't have anything on the right. And then I have my minus 2x plus 2x plus x. Okay, I get the E's, so we add straight down. That's that black here. And we get our equilibrium expression to be 1.6 times 10 to the negative fifth equals products over reactants. Now this 2x here, all right, this is where it kind of comes into play that we're going to kind of not worry about how much it is shifting or moving by. It's not big enough to matter. That's what I have written there. Not big enough to matter. That little bit of a minus 2x is not big enough to really change that 0.5. So when that's moving, it really doesn't actually move, okay, very much, or much compared to what it started with. So we then just get rid of it totally, leave it as 0.5, square my 0.5, and then solve for your x. So when I solve for my x, I'm going to get 0.01. Notice how that's not very much compared to 0.5. So I then subtract and figure out my equilibrium concentrations for each one, and we get 0.5 for the original NOCl. That one's not going to change. And then 2 times x, and then x for the two other concentrations.